Rhonda Martens was a student who did her dissertation working with Bill. Bill often talks about this legendary Kepler seminar in which, I don't remember how many students there were, but every...
3 philosophy and 1 astronomy teacher from...
Right, and all the papers from that course turned into published papers and...
The 3 philosophy papers.
Or 3 philosophy papers, and Rhonda's work in that course eventually culminated in her book, and even though her title on the program has to do with Keplerian Analogy, she's not going to be talking about Kepler today. The actual title of the talk is Fertility. Is that correct? That's correct. Okay. Rhonda.
Thank you, Wayne. Okay, so fertility, letter U rather than fertility. So thanks Wayne for inviting me. It's a real pleasure and honor to be here. As you know, Bill was my thesis supervisor, and you couldn't ask for better. One of the things that I was reminded of when you suggested that Bill curb his enthusiasm during my thesis defense, one of the rules is that the thesis supervisor is gagged. Not literally. And it turns out that the process for doing a dissertation defense is that they ask you questions until you get exhausted and can't answer anymore. And at the moment that you break, that's when they give you your PhD. And the question that broke me was actually an incredibly easy and simple question, one which under any other circumstance I could have managed with no trouble. But I couldn't understand the question. I kept asking it to be rephrased. I had no idea. And Bill was sitting on his hands, rocking back and forth in frustration because he's like, she knows it, here's the answer. But actually this time, if it turns out that there is a question that someone asks and I know the answer, but you want to give it, feel free. Anyways, I learned a lot from Bill, which is one of the reasons why I recommend him highly as a thesis supervisor. If there are any students in the audience who are trying to decide, although I guess he's retiring, so or things otherwise, I would recommend him highly as a thesis supervisor. And one of the reasons why I do is because I learned some very important concepts from Bill that have influenced everything that I have to say about the philosophy of science. Even if they're not explicitly there, they're there in the back of my mind. And I think there's a cluster of concepts in particular that's really nicely summarized in this quotation from a paper that Wayne and Bill co-wrote. It's, does everyone have a handout? Okay, it's the first quotation in the handout. The quotations are all up here, so it's just which you prefer. It says, the full import of empirical evidence is realized only by adopting a richer ideal of empirical success than predictive accuracy. And that the ability of a theory to turn phenomena into accurate, agreeing measurements of causally relevant parameters contributes to the evidential support of the theory. This sentence says a lot. The first thing is, of course, that predictive accuracy is not all there is to say about empirical success. And since a lot of problems in the philosophy of science are generated from the assumption that predictive accuracy is all there is to say about empirical success, this has the potential to dissolve a number of those problems. But the other part has to do with the ability of the theory to turn phenomena into accurate agreeing measurements. First, I want to focus on this having to do with what a theory does, right, in terms of organizing the phenomena. When you look at a theory, it can be structured in a certain way, or it can hang together in a certain way, so such that it makes relationships between phenomena apparent, relationships that might not have been apparent otherwise. Bill often talks about this in the context of new, but my favorite example comes from Copernicus. So under the Ptolemaic system, since the models for the retrogressions of the planets are all constructed individually, you don't have to pay attention to what's going on with your model for Venus when you construct your model for Mars. Now, that's not the case under the Copernican system because the motion of the Earth relative to the motion of the other planets is the cause of the retrograde motions. And so you have these relationships between the motion of the Earth and the retrogressions. These relationships are what Bill often refers to as systematic dependencies. So if we go and we use the motion of Mars to make measurements of the Earth's orbit, that will then put constraints on what our measurements of, say, the retrogression of Saturn is supposed to be. Okay, so theory is going to place constraints on that. Now, one of the things that this got me interested in was in the structure of theories, or how theories hang together, to speak a little bit more loosely. I'm not going to give a defense, by the way, of the evidential significance of systematic dependencies. I'm just going to assume it because I think it's obviously right. I'm going to assume it for the purpose of this talk. Instead, I want to talk about another structural aspect of theories, mainly the structural aspect that allows for a theory's extendability or its fertility. So here's a brief outline of the talk. I'm going to be talking about McMullen's notion of U-fertility and also his notion of E-fertility, to be defined shortly if you're not already familiar. I picked McMullen because there's not a whole lot of literature in the philosophy of science on fertility. It gets mentioned frequently as a virtue of theories, but not a whole lot of work being done on trying to make this notion precise. McMullen's is one of the seminal articles on this, and pretty much every other article on fertility mentions McMullen's notion. Now, McMullen's idea of fertility depends pretty crucially on the metaphors and analogies that occur within a theory, and so after that I'm going to be talking about the nature of metaphors and the nature of analogies, and some attempts that have been done in the cognitive sciences to go and model metaphorical and analogical reasoning. Now, there are quite a few attempts, and they're all different, and we learn different things from them. I've chosen James Martin's Linus model and also Gentner's SME model. Of course, these are all acronyms. My reasons for choosing this model over that model just has everything to do with time, and my reason for choosing those models rather than some others, well, they're actually rather idiosyncratic. I chose Gentner's model because it actually just helps me set up a point that I want to make at the end of the talk. But I could have chosen other models, and we would have learned different things from choosing those other models. So I want to make sure that you're aware that this is just a for example. And of course, once we finish that, we'll talk about the implications, what we learned, and since we're philosophers of science, or we're interested in philosophy of science, we of course have to talk about some of the non-issues involved. So that is a very brief outline. So on to McMullen's notion of fertility. This wouldn't be a philosophy talk if we didn't draw a distinction, or two, or five. So I'm going to start with the first one, and this is the distinction between P fertility and U fertility. The P in P fertility stands for proven fertility, and so the U stands for unproven fertility. Now, McMullen's notion of fertility is something that applies to a theory as it changes over time. It's not a property that a theory has if you just take a snapshot of it at a particular point in time. So it's an evolutionary notion. And a theory, when it is born, will be mostly U-fertile. And a theory, as it matures, will become more and more P-fertile, where the theory is P-fertile if the various modifications and extensions of it end up being tested successfully. Well, it's tested and then found to be successful, right? So there's a successful test, and then the theory itself was successful. Now, if we're interested in confirmation theory, then McMullen says that we're going to be more interested in P fertility than U fertility, because U-fertile theories do not, well, their epistemic status is unknown. So my apologies on the handout, if you're preferring to use the handout for reading quotations, this is actually the last McMullen quote because I made some very last minute changes to talk. The rest of it is all in order. To say that a theory has a high degree of heuristic potential, or U-fertility, tells us nothing of its epistemic status. Indeed, the greater its heuristic potential, the more problematic its present epistemic status may well be, since it contains so much by the way of untested suggestion. Okay, now, fertility is still important, however, because in order to make the claim that we have to look at the historical path that a theory takes, McMullen needs to say something about how the p-fertile theory is related to the u-fertile theory. If he doesn't do that, then we could say something like the value of the p-fertile theory just is decomposable into other epistemic values like its predictive accuracy and so on, or simplicity. Okay, so we need to talk about the transition and how that occurs between u-fertility and p-fertility. And McMullen doesn't give us a set of necessary and sufficient conditions or anything like that, so I'm just going to give you a whole bunch of quotes just so that you can get a feel for what he has in mind. So, the first one. Okay, the development of the original theory is not just an exploration of its logical implications. Rather, it is a matter of analogy, of tentative suggestion, of plausible modification in light of a particular opportunity for expansion or in the face of a troublesome anomaly. The development is natural in the sense that it is shaped by the structures of the theory, but not so natural as to be rule-governed, as it's added. There is a need for a creative act of imagination, a what-if, in which the resources of the theory are exploited to construct a new possibility, which on testing proves to be a fruitful insight. Okay, so again, just to emphasize, we have in not being rule governed. I don't know exactly what he means by this, so we'll just leave that open for the time being. I'm going to suggest that there's a sense later that there's a sense in which there are rules that govern it, although they may not be the kind of rules that he has in mind. In particular, just to give you a sense, they may not be rules that are sufficient to force a unique modification. In other words, the theory has to extend in this direction and not in some other. But it doesn't necessarily mean that there are no rules at all. Okay, next quotation. Now, the resources of the theory are evidently of two sorts: the implications derivable from it by means of formal rules, and the resources it displays as a metaphor, i.e. as a tentative conceptual juxtaposition of elements capable of suggesting to the creative mind a whole range of possible further developments of the theory itself. These metaphors suggest modifications that are plausible extensions, and the experienced scientist will have a certain feel for considerations such as these. The theory directs the mind not coercively, but tentatively by analogies and hints. The mind's response to it will be highly individual in consequence. I just want to point out one thing about this quotation. He is taking the high individuality as a consequence of the theory directing the mind by analogies and hints. Okay, so there is this notion that we don't have a set of rules that govern the extension of a theory or the transition from u-fertility to p-fertility, and that there is an idiosyncratic aspect to it. So it depends very crucially on the creativity of the individual scientist. Okay, so as you can imagine, there are some common criticisms of this view. Actually, these common criticisms are not ones that I think that McMullen would disagree with. So I think they missed the mark a little bit in terms of being criticisms of McMullen. So Nolan on u-fertility says, much room for improvement isn't high praise on the report part of the theory. And of course, McMullen agrees that u-fertile theories have an uncertain epistemic status. So he would say, you're absolutely right. It's not. And then we have from Brady, this is perhaps the most representative criticism. Without a clear notion of what this notion of metaphorical extension means, the thesis borders on the vacuous. As far as I can see, we nowhere find a clear statement of McMullen's concept of metaphor. This is not surprising, since the concept of metaphor is notoriously difficult to pin down. The prognosis seems far from right. Again, I think McMullen would say that it's actually in the nature of the transition from eufertility to p-fertility that you can't give anything other than a vague account. To give a precise account would actually be to misrepresent the process. I'm going to say something different than that, rather than, yes, I agree. Here we get my thesis. I want to make 2 points. First is to Brady and also to McMullen. It really depends on what your theory of metaphor is, whether or not you can say something relatively precise or whether you can't say anything at all. And while Brady does say that the literature on metaphor has controversies, as far as I can tell, the controversies don't run any deeper than in any other area of philosophy. And I'm pretty sure that Brady would not want to say something like any thesis that depends on some area of philosophy is so vague as to border on vacuous. I have a friend in sociology who might agree to that and accuses me of vacuousness on a regular basis. But for those who are perhaps more sympathetic to the discipline of philosophy, we wouldn't want to say that. My second thesis is more directly to McMullen, and that is that we actually can say something about the evidential significance of eufertile theories. Now, I chose my words relatively carefully here. Evidential significance is not the same thing as it has already been confirmed. So, there are things that we're interested in other than whether or not a theory has already been confirmed, whether or not it's particularly accurate. And I want to highlight that a little bit later on in the talk. Okay, so let's start talking about metaphors. I wrote my master's thesis on metaphor a long time ago, and I'm pretty sure that most of what it said was wrong, but I think the unwritten subtitle of my master's thesis was Why Donald Davidson is the Devil. Because I'm pretty sure that's what I saw, and I saw myself as kind of a David versus Goliath. Anyways, here's, Davidson gives us one account of metaphors, and here's a quotation from the first page of what metaphors mean. Very influential, and actually now on reflection and actually rereading, I think he has a lot more to say that I find interesting. But if you look at a quotation like this, there are no instructions for devising metaphors, there's no manual for determining what a metaphor means or says, there is no test for metaphor that does not call for taste. If this is your going theory of metaphor, then it's easy to see why, if eufertility depends on metaphorical extensions, why there's really nothing more to say. There are, however, other theories of metaphors out there. So, for example, we have an error and paraphrase account. Basically, the way this works is you encounter a metaphor, say Juliet is the sun, and your first move is to interpret it literally, and then you realize, well, Juliet's a girl, and the sun is a huge burning ball of gas, so Juliet can't be the sun. So they must have meant something else, right, based on the principle of charity. And then you do some problem-solving activity to try and figure out what Romeo must have meant. Okay? And the paraphrase that you give afterwards, which maybe would be something like, Juliet is really important to Romeo, that's going to be the meaning of the metaphor. You can draw out the meaning of that quite a bit more, by the way, and you can draw it out in such a way that it actually makes sense of the story, like why there would be suicide at the end. Because you can't live without the sun. But in any case, once you get a complete paraphrase, you'll just have a bunch of literal sentences, and those act in the way that any other sentence, unproblematic sentence like the cat is on the mat, does. And so there's no difficulty with metaphor. We also have transference accounts. Some people who are transference theorists are also error and paraphrase theorists. In other words, how do we explain the paraphrase? Well, we explain it via some notion of transference, and some are not. They also differ in terms of what gets transferred. So when you have a metaphor, to use Black's example, like man is a wolf, you have the source domain, namely the domain of ideas about wolves, and they get transported or transferred into the target domain of thinking about man, and they organize it, right? Or they carry over stereotypes. So if your stereotypes of wolves are that they are predatory and vicious and so on, then what we're going to go and transfer those stereotypes to our thinking about man. Kitay has a different view of this. She thinks that what gets transferred is primarily structure. So words get their meaning from their position within a semantic field. Semantic field is going to have two main parts to it. It's going to have a content domain. So a content domain determines what sorts of objects or processes, etc., that we're picking out in the world. It can be general, like the content domain of all the things that one can possibly experience. Or it can be really specific, like my favorite ice cream flavors. And of course, content domains will overlap in various ways and have relationships between them. And these content domains themselves will be organized by what she calls a lexical field. These are a variety of different kinds of relationships. Just to give you a couple of examples, words can be related to each other by being opposites, black-white, or they can be related to each other in terms of being basic terms versus peripheral terms. So with colors, basic terms, blue, red, yellow, peripheral terms, puce, chartreuse, aquamarine, and so on. You can have rank ordering, so corporal is higher than private. You can have cyclical ordering, so spring comes before summer, and so on and so forth. There are lots and lots and lots of different ways of organizing these fields. And when you go and offer a metaphor, one of the things you're going to do is you're going to transfer over the relations from the source domain to the target domain. So if I say, you're the captain of my heart, what I'm doing is transferring over a rank ordering, and I'm saying you're basically in charge of my emotions, or something like that. So now Kitay talks about how one of the things that we do is we will often make this transference when we have a relatively unformed content domain, or unstructured content domain. So when we first started learning about electricity, we used a lot of information from the domain of fluids in order to organize our concepts of electricity. And this shows up in our now literal language, like electric current, draining and flooding batteries, and so on. Okay, now if you read Kitay, you'll see that she actually gets really, really specific at times, and specific enough that you think, well, I wonder if I could actually come up with a computer that might be able to represent these various transfers of relationships. And something like this has been done by James Martin, although the application is a little bit more prosaic. He's been working on coming up with a helpful help program for your computer. And of course, one of the problems is if you don't know the name of what it is that you're wanting to do, then you can't find it in your help program, and usually that's what you want to know. If you already knew the name of it, then you can find it in the menu. And so just to take a really simple example, if the word for opening a program is execute, and the word for closing a program is quit, but you don't know those words, then you're going to have a hard time. In fact, you might type in something like, how do I enter this program, and how do I exit this program? Those are pretty standard conventional metaphors. They're spatial metaphors that are applied to programs. They're so conventional as to be near dead, but in any case, if we look at conventional metaphors, we'll see that there are certain metaphors that are used very frequently in a lot of different domains. So in other words, there's a source domain that tends to be very common to a lot of different target domains. Martin has relied pretty heavily on the work of Lakoff and Johnson on conventional metaphors. But again, I think you can take this as a for instance. These are sociolinguistic studies of what sorts of metaphors organize our ordinary ways of talking. So I'll move on to conventional metaphors from Lakoff and Johnson. Here are some examples. X is a building, right? We use building metaphors to organize a lot of things. X is vision related. There are a lot of vision metaphors, war metaphors, journey metaphors, fluid, plant, machine. These are just, if you just start observing the way that you talk, you'll notice that these metaphors come up over and over again. So here are just some specific examples. So if you think of theories or arguments as buildings, then you can say things like the foundation of a theory or its framework, a shaky or solid argument, constructing, deconstructing, so on and so forth. Ideas are commodities, that idea won't sell. Often we talk about ideas as procreation, so Locke is the father of classical liberalism, or cognitive psychology is still in its infancy. Okay. It's actually important to give an answer to the question. There are certain metaphors that we pick more often than others. We don't actually have to give a very deep question, but if we're going to program them in, we have to know what ones they are, so we have to have an idea of where to look for them. Some people argue that we pick them on the basis of familiarity. So one of the first things that we do in life is we learn how to orient ourselves in space, which is why spatial metaphors are very common. I don't think we have to give some sort of evolutionary account or evolutionary story of why these metaphors rather than some other. Partly because I think if you look at different people, you might find that, or different cultures, different time periods, that different metaphors figure prominently. I'm not going to talk right now about a different culture. I'm going to talk about a different person. This is my favorite example of a metaphor user. I just couldn't help myself. So if you look at Kepler, there's tons of metaphors and analogies throughout his work. And one of the things that he believes is that God created the universe in order to instantiate certain types of laws that have aesthetic properties. And by looking at these aesthetic properties, we can see them as truth markers, right? In other words, God would create something like this that makes this law a plausible candidate for being true. The laws in mechanics have the right sort of truth markers attached to them, so they're likely true. And since God would want to replicate these aesthetically pleasing relationships in as many domains as possible, this actually goes and justifies the transfer of the laws and methods of mechanics from mechanics, which then was the study of machines, over to celestial physics and to optics as well. So my point here is that we actually are going to, if we're going to set up a psychologically realistic model, we're going to have to look at the actual conventional metaphors that we use. We can't tell a story about why some metaphors are, say, necessary. They're not necessarily necessary. Okay. So how might we go about modeling these computers? Well, there's a couple different strategies. One is the word sense strategy. The basic idea here is we treat these metaphors as dead metaphors, therefore as literal, and so we just simply supply the dictionary definitions to the computer. So exit a program is going to be given a meaning, namely to quit the program. There are two related problems that Martin has with this particular approach. One has to do with programming economy. The economy is generally seen as a virtue in cognitive science, and if you have to go and add a different meaning for every use of enter, since spatial metaphors are used so frequently, there's going to be an awful lot of different meanings for words like enter or exit or into or out of, and so on. So you're going to have to add perhaps too many entries. More significantly, you're actually going to lose the connections between the entries and the inferences that it allows you to make. So let's suppose that you're familiar with the definition of enter, as in how do I enter this program, but you haven't encountered the definition of exit. You can actually go and infer what exit must mean based on the spatial metaphor that's used. Okay, so if you go this route, you actually lose those connections, or those connections have to somehow show up in the dictionary. Okay, there's another strategy. One, this is based on the error and paraphrase account of metaphor. So the computer encounters a metaphor, Juliet is the sun, and then it has criteria for evaluating this. And one of the things that the computer notices is that Juliet is classified as a girl, and girls are classified as things that are not sons, and so then it realizes that this can't have been intended literally, and so then a problem-solving engine is brought in to handle this. Now there's some psycholinguistic data that suggests that this isn't the route that we want to go. In particular, they've done some tests where people are presented with literal sentences, metaphorical sentences, and if they don't differ too much in terms of complexity, and we'll leave that whole can of worms alone as to whether or not we can actually say that these don't differ in terms of complexity. But it actually doesn't take subjects longer to compute the metaphorical sentences than the literal ones, which suggests that there may not be an extra task that they engage in. The other thing is that in a lot of different contexts, we may go for the metaphorical meaning first. So if I say I ran into a pole, and you might be concerned about the car once you've ascertained that I'm okay, and then I say, no, I actually was jogging, and I literally ran into the car. So this idea that we have to assume that it's a literal meaning first, and then only go to a metaphorical meaning when the literal meaning doesn't make sense, doesn't seem to be correct. Okay, so what does Martin have proposed instead? He's got a program that he calls Midas, and the way this works is the conventional metaphors, once identified, are actually programmed in. And another feature of Midas is that it doesn't actually give preference to literal interpretation. It actually goes and searches for all possible coherent interpretations, and then it'll have a variety of candidates left over. If there's only one, then we're good. If there's several, then perhaps some sort of context machine is going to have to be brought in. But no preference is being given to the literal. And so it finds metaphorical meanings even when a coherent literal one is available. The example that Martin gives is McEnroe killed Connors. So we're talking about tennis players, and one would expect that what this means is that McEnroe bested Connors in a tennis match. And then of course you'd say, no, actually he stabbed him with a knife. So that's a case where we go for the, so both are actually coherent from Midas's perspective, because Midas is aware of the metaphorical meaning of kill, and since they are both tennis players, tennis players are people who participate in sporting events. Sporting events are cases where people can be, killed in that metaphorical sense, therefore it makes sense. But also McEnroe's and Connors are animates, and animates can play the role of killer and Kelly. So both of those interpretations are coherent, and that's of course when the context gets brought in. But that's true for us as well. Okay, here's some principles. There's a lot. I'm just going to summarize for reasons of time. We started a little late. Okay, words are going to be defined in such a way that they're going to have relationships to each other. He talks about correlationships where have and give are correlated to each other because they refer to the possession of an object. He gives more details on how that works, but we don't have time for it. Now, when a metaphorical transference occurs, correlationships with the target domain are going to be transferred over to the source domain. Okay, and correlationships are used to make inferences and allow synonym substitutions. So if you can exit a program, you can leave a program, so those are going to be defined in such a way in the space domain to be correlated. Here's what I find most interesting about Midas. It can handle certain kinds of novel situations. So if you haven't programmed in this use of kill in how can I kill this program into Midas, what it's going to do is, the first thing it's going to do is it's going to look for similar metaphors. Similarity is going to be determined, or it's going to be defined by matchings of core relationships. So, for example, it's going to look for known metaphors and inferences that are correlated to kill a program. So here we have a process is a living thing, termination is death, And these are correlated in a known metaphor, namely to kill a conversation. And then if you look at programs, programs are also defined as processes that can be terminated. And so because of these similarity relationships, they're judged similar to conversations. And so killing a program is then interpreted as terminating a program, which is interpreted as exiting a program. Midas also uses two other routes. We can extend the core, right? So if I can exit the program, I can enter it, and also some combination of 1 and 2. Okay, so if we bring this back to U-fertility, one way we could interpret U-fertility is that it's going to depend on the richness of the system of core relationships in the source domain, and then the relationship between U-fertility and P-fertility is going to be based on whether or not we can trace the development through building up novel metaphors through this particular process. This comment is kind of a free association comment, and I'm actually going to skip it for reasons of time. There's some things that Midas doesn't tell us. There's actually a lot of things that Midas doesn't tell us. The first is that because it's obviously very sensitive to the programmer's choices, even those choices that are based on sociolinguistic studies, we don't actually get an explanation of our similarity judgments. Those are actually given by the programmer, so the program itself doesn't tell us about that. Midas has also been tested only in very limited types of cases, and of course we're interested in U-fertility, so that's going to involve more complicated cases. Martin thinks that his program is extendable, but more work needs to be done on that. Also, for our purposes, we would need to modify Midas to handle novel analogies, and what I have in mind is something like this. Okay, so if we use a Keplerian analogy, creative forces like light is like the motive force that moves the planets around. We can obviously define the core relationships in the right sort of way so that the computer can understand sentences about motive force. So I've gone and given sentences about light. Light's a process that emanates circularly. Light spreads out in straight lines. Light spreads out evenly. The motive force is a process that emanates circularly from a central body. Therefore, it spreads out in straight lines. It spreads out evenly. Now, we're not that interested in figuring out what these sentences mean. We're actually interested in figuring out whether or not we can make these inferences. So that's why I'm going to be shifting our discussion to analogies. Okay, you can't talk about analogies without talking about Hesse and Keynes. Hesse did some really important work on the use of metaphors and analogies in science, and we're going to have a few more distinctions. So when you look at the relationship between source and target domains, you're going to notice that some relationships transfer over and some don't, and then there's some where we don't know whether or not they should transfer over. So apples are red and round and they're good to eat. Balls are red and round, they're not good to eat. There's a relationship that doesn't transfer over. The relationships that don't transfer over are what is referred to as a negative analogy. The ones that do transfer over are positive analogies, and the neutral analogy refers to those areas where we don't know. So for McMullen, U-fertility takes place in the domain of neutral analogies. Okay, another distinction. We have to look at horizontal versus vertical relationships. So if we're going and drawing an analogy between water flow and heat flow, where pressure causes water flow and temperature causes heat flow, the relationships within a domain are the vertical relationships, and the relationship between domains are referred to as the horizontal relationships. This is going to become important later on. Okay, so we need to talk about what makes an analogy fertile versus what does not. And Gettler has a proposal. She says some of these scientific analogies have suggested deep research, while others have merely provided a kind of spurious feeling of comfort. Now she's got a way of distinguishing between these two. So here's her proposal. We'll see if we agree with it. The first thing we need to consider is the source specificity. So if, for example, you're going to try and explain magnetic attraction in terms of romantic attraction, given that we don't know very much about romantic attraction and how it works, that's not going to help us in terms of understanding magnetic attraction. So we need to have specific knowledge about our base or our source domain. Second has to do with how clearly or how well our information from the source domain maps onto the target domain. So we have to look at the horizontal relationships. We also need to look at what's called the richness. This is the number of attributes mapped. This isn't going to turn out to be very important in terms of the fertility of theories, because Gentner thinks that with a good analogy, you aren't actually going to map that many attributes. Okay? What you're going to, in fact, when you map a lot of attributes, what you're looking at really is literal comparison rather than an analogy. But you still need to consider it. What she does emphasize is the systematicity of vertical relationships. So are there a lot of relationships between the various components of the source domain? What is the nature of those relationships? Are they intricate and systematically connected up? The more systematicity the source domain has, the better analogy it's going to actually provide. Okay, so standard example of the fertile analogy, Rutherford's solar system model of the hydrogen atom. This quotation is at the very bottom of your handout. I'm going to leave it for you to have a look at since I'm running short on time. Okay, so Gentner has proposed an engine, a structure matching engine, or SME. And the way that SME works is it maps the structure from the source domain to the target domain. So we're going to use the usual sort of calculus for representing to the computer what's actually going on in a physical system. So we have entities, and relations, and attributes, and functions. We're going to ignore functions. If you look at the back of your handout, you'll see that we have a physical situation. We have a large beaker of water, and then we have a small bottle of water that are connected up. And we also have a cup of hot coffee or warm coffee, and on a silver bar at the top we also have an ice cube. And the analogy in question here is that we're going to argue that the greater pressure is going to cause water flow, and the greater heat is going to cause temperature flow. So that's the analogy. Now if we ignore the attributes, there are various features that we're going to ignore. We're going to ignore the fact that the water and the coffee are both flat-topped and shiny. Okay, so those aren't very important. Instead, we're going to focus on relationships. If you look at the bottom right-hand corner, where we have a representation of the two situations, we're going to actually focus on the relationships which are indicated by the diagonal lines. So we have relationships of greater than. We also have a higher order relationship of causation. So the greater pressure causes the flow of the water. And Gentner's SME is going to prefer transferring over relationships that are embedded in a larger system of relationships. Okay? So it's going to notice that we've got a connection between the greater pressure and the greater temperature, namely the matching relationship of greaterness, and we're going to transfer that over along with the causal relationships. There are questions that you probably have about that. I think we'll reserve that for the question period. There are questions that a lot of people have about that. One question is why would we transfer relationships just because they're more systematic? And another question is, given the way that this is represented, Gentner can represent it in such a way so that we're going to get the right analogy for free. Okay, so this is a criticism given by Bartha, Brontes, and pretty much everyone else. So the mapping is predetermined by programmers' choices. Another question is that some potentially successful structures get transferred, others don't. So, for example, you can catch a cold from someone, but they don't throw you a cold. Okay, so this is a relationship that does not get transferred over. And so we actually have to look at conventions of transfers in order to be able to answer that question. Or we have to look at something other than just its place in a systematic relationship. Okay, here's why we're doing this. Now, Gentner and Martin are trying to come up with a psychologically realistic model of metaphorical and analogical reasoning. I don't think it's necessary to say that they've completed their job. In fact, it's pretty clear that they haven't. I don't think it's necessary to say that they've completed it, or even that it's completable, in order to say that we've actually learned something from this in terms of being able to make more precise Mullen's notion of fertility. One of the things that this helps us do, and I think George can appreciate this better than I can, is that in the process of actually trying to develop a computer model, you have to get really precise on what your commitments are. And that already is a large advantage. Moreover, you can actually run simulations or tests, which gives us an avenue for being able to test some of our assumptions to see whether or not they're going to produce data that's psychologically realistic. And presumably there's going to be a feedback loop between results from neuroscience, psycholinguistic data, sociolinguistic data, and these test runs. And as we articulate more and more, at least what we don't know, a certain amount of progress is actually being made. So the picture that I want to take a stand against is that is something like, well, fertility involves the use of metaphors and analogies. Our responses to these are highly idiosyncratic, so there's nothing more to say. I think there is a fair amount more we can say, even if it's far from complete. But there are, of course, problems. One is, suppose we come up with a completely psychologically realistic model. That only gives us a possible account. It doesn't give us an actual account of, this is in fact how the brain, how we're actually doing it. And it certainly can't be used to predict accidental developments. So when you look at scientific fertility, a lot of it has to do with things that we couldn't have known were going to happen in the laboratory. So mold grew in the petri dish. That's not something that can be explained by any of the foregoing. I do think that that's actually a different notion of fertility than what McMullen has in mind. McMullen is talking about plausible extensions of a theory. He's not talking about what we do with a theory when something new comes up. So that's the kind of fertility that I'm focusing on here. But most importantly, even if we come up with a completely psychologically realistic model, that doesn't give us a normative account. And we want to know whether or not we ought to make these inferences, not just whether or not we do. And now we're just going to close with a few comments about that. So Gentner thinks that we actually ought to prefer analogies with highly systematic relationships in the source domain that then get transferred over to the target domain. I'll get to that in just a second. She also thinks that we need to look at validity. Just to comment, Gentner is not using the word validity in the way that a logician would. What she means is that it has given us a test, and the theory in this the test has been successful. So, but validity, of course, belongs to P fertility, and we are looking at the relationship between U fertility and P fertility in how we make the transition. So, we're going to focus on systematicity, because that's something that can belong to U fertility. Paul Bartha, hot off the press, Oxford 2010, has just published a book called By Parallel Reasoning, which gives a really nice extended treatment of how we can evaluate arguments by analogy. It's considerably more sophisticated than your average textbook on logic, which gives you some rules of thumb and some basic advice. I just got it. I haven't had a chance to fully digest it, but in any case, first comment on that, there is quite a bit that we can say about how to determine when our analogies are likely to be profitable. And he says it. But I'm going to focus on criticism that he makes of Gentner, and this is, so Gentner's proposal is that we should look at the systematicity of the theory, and that's going to tell us whether or not we ought to make the inference. Bartha points out, rightly, that systematicity is not the same thing as plausibility. You can have a systematic system of relationships, but of course it doesn't mean that they're true. Okay? I think this is absolutely correct, but I don't think that it takes us to the conclusion that Bartha wants us to draw, which is namely that systematicity is not going to belong in our normative theory of analogies. So here's an argument that I think we should actually reject. So systematicity doesn't give us plausibility, therefore systematicity doesn't play an important role in our assessment of U fertility. And in order to make this case, I want to draw an analogy between the systematicity is not plausibility and another argument in unification of simplicity is not the same as truth. And again, I agree that if you have a theory with unified power or a theory that is simple in the right sort of way, that doesn't mean that the theory is actually true, okay? Or even more likely to be true or anything like that. It may well be the case that the world is complex. However, if we're interested in testability instead of just truth, then we are actually going to be interested in the right sort of unification or simplicity, and we are going to be interested in the right sort of systematicity. In particular, this is going to allow us to access the world in a way so that we can test our theory to find out whether or not it's going to test successfully. Okay, and if the source domain has the right sort of systematicity, if in fact the source domain contains systematic dependencies, those might be transferable. So I'm not, by the way, saying that this is the only way that a theory can come by having systematic dependencies. What I am saying is that this is one way that we can actually construct a theory so that it's going to have systematic dependencies, which we want to have in our theory. But I actually think that there is a slightly deeper connection between systematic dependencies and U fertility. And it goes something like this. So part of the value of systematic dependencies is that they allow us to make the observations more informative. Okay? And they actually allow us to access certain kinds of information and access certain kinds of predictions in a way that we might not be able to otherwise. And here's my intuition. If you have a theory that is really extendable to a certain amount, but it doesn't contain any systematic dependencies, then it's actually going to be less U-fertile than a theory that's equally extendable, but has systematic dependencies in it, because presumably fertility is going to have something to do with whether or not a theory increases our chances of getting information about the world. So I do think that there is a connection between systematic dependencies and U-fertility, and this is all based on this notion that we want to make our observations informative, and fertility is an important component of that. Okay, I'm going to close because I've run over time, and if that wasn't clear, then we now have an opportunity to make that clear.
Okay, we have about 20 minutes for questions, and what I'll do is I'll keep a queue in the order I see hands. If you have a comment or a footnote to add to a current discussion, then raise a finger and that will allow you to jump the queue. But if it's a new question, raise a hand. And George.
I want to propose an example for you to study closely. You brought it up, electric current. Both heat flow and the flow of electricity date from the late 18th century as far as I know, and they really have nothing more than the flow of caloric being measured by the Lavoisier-Laplace calorimeter and in the Franklin, etc., one fluid or two fluid. But the first time we had controlled electric current was in 1800 when Volta announced the battery. Now, there are several things very interesting about this. I'll just list them to tell you why I think it's an especially useful example to observe, to consider. First of all, of course, nobody's ever observed electric current itself. And the best way to demonstrate that is it took a century to realize which direction it was going. But the more striking thing is since 1840s, we've always measured it using an electromagnet, what's called a galvanometer. Now that word was introduced in Ampere's classic paper on electrodynamics by Ampere, telling you this is the way to measure electric current, not the way we have been doing it, by the displacement of the electromagnet. So I like to give this question, I'll do it what I always do with students. How in the world did Ampere discover his law, which is a law relating electric current and electric field, which is a force field around it, if he had no way to measure current? How did he measure current? Anybody know? It's a fascinating answer. The number of voltaic cells. That was the sole way of measuring current until the 1830s. And of course, it's a terrible way, and it gives you no sense of flow at all. So something very funny is going on with the notion of electric current that doesn't really get resolved, more or less till Bohr's doctoral dissertation, where he's proposing something, the electrons flowing through a conductor. And even that doesn't get worked out till the 1930s. But I just propose it as a particularly good example to play off of the two here, because I think they work very different from one another, and I think the electrical one's going to show you a lot of things going on.
Thank you. I don't actually have a response to that. But
No, I was proposing it for you more thought. I don't, if you haven't looked at the history, I don't see why you should have.
Brian was next.
I really liked your beaker and coffee cup example, and I think, I agree with you that these analogies can lead one towards building a new theory that can direct you, in important ways. But my question is about what role these analogies can play, if any, in things like confirmation. So, for example, if, imagine that I was talking about, I had reason to think that some other system which I had very little empirical access to, obeyed similar laws to these two systems. Basically, it's a thermodynamic system, like a black hole or something. Could I do experiments on these beakers and draw conclusions from those experiments for those empirically inaccessible things just on the basis of these analogies? So how far can I take this in terms of confirmation?
Well, the answer is going to be it depends. Well, two parts. It depends and not all the way. So one of the things that we're going to need to look at is not just how well we know the source domain, but how reasonable are the inferences, how reasonable are the connections between the source and the target domain. So if we already have really good reason to think that source and the target are not just related analogously, but perhaps related so closely that they are very likely the same kind of thing, or close to the same kind of thing, then we can go and make tests in one kind of case, and that can give us some confidence to a certain level in the other kind of case. I mean, it's not the same thing as actually testing directly. Okay? So standard case rat studies for medical research, that's a case where we use an analogy between rats physiology and human physiology in order to determine the effects. If we had something even closer to human physiology, a creature even closer, so close that it's very nearly human, then we would definitely increase our confidence in terms of the test, if we couldn't test humans. So if, for example, pregnant women aren't allowed to take any drugs at all because nobody ever tests pregnant women. I mean, by the way, those are both hyperbolic statements, but if you, for example, if a person under a certain kind of condition was extremely close to being like a pregnant woman, but not actually pregnant, such that we were willing to then one might be able to draw further inferences about whether or not that particular drug is safe. So, but yeah, it depends two things, how well we know, say, the vertical relations in the source domain, but then more importantly, how strongly are the connections. The other thing you need to look at is, if you look at the system of relationships, and you have, in the vertical relationships, maybe you have a causal inference. So we know P, Q, and R, and we know that if we have P, Q, and R, that we can then infer S. Okay? And if in our target domain we have P and we've tested it, it seems to be the right sort of P, the same sort of P, and we've got Q, and we've got R, and we tested that, and we seem to have the right sort of Q and R, then we get a more confidence in S than if we're, say, uncertain of this. Or, I mean, there are other complexities that we have to think about, like we get P, Q, and R giving us S unless T, and we're not sure about the status of T in our target domain. So, example, we're trying to figure out whether or not Mars could have supported life at some point in time. And we draw an analogy between Mars and Earth. We're going to have to take into account, life can, so here's a bad analogy. Life can happen on a planet, the Earth is a planet, Mars is a planet, therefore life can happen on Mars. There are a variety of things that can interfere with the production of life, and we need to look at whether or not Mars has those interfering features. And the list goes on. There's actually a fair amount that one can say about this.
I just want to add a footnote to that. I think that's exactly the right kind of answer to give. We have to have good reason to believe that the systems are like each other in the right side of the way. The way you put it is, are the same sort of thing, but I would...
Well, that would be the ideal.
Well, not necessarily, because they could be very different things, sorts of things, if they have the right kind of strict structural similarities, which is the case for the example that Brian and I are actually thinking about. Brad, you want to tell us why you asked that question?
Okay. Wayne and I went to saw a very interesting talk last weekend about black hole thermodynamics, which you have exactly this problem, I just described, and it's, tightly related to the kind of talk you're giving right now, in which basically people are doing experiments on water systems in order to learn about Hawking radiation of black holes. And the question is, are you really learning about black holes when you're doing these experiments with water?
Because there's a structural analogy in equations in the physics between hydrodynamics and black hole thermodynamics, and there are the hydrodynamical equivalent of a black hole is what Bill Underwood calls a dump-hole, where the rate of flow of water is actually faster than the speed of sound, so sound can't get out of it. And Bill really he is doing experiments with water tanks to find out about what black holes do. Dylan was next, I think.
I'm going to ask the not quite as thoughtful question because I haven't finished thinking about my thoughtful question. To some extent, is McMullen trying to, maybe not consciously, ruin the idea of U-fertility?
Is he trying
to ruin it? Like to say, because in some of his works he's got this idea of really promoting hypothetico-deductive methodologies and means to show we can be as creative as we want and produce meaningful and good scientific things. So, is part of what he's doing trying to undermine this idea that U-fertility is something valuable?
Not in this paper. The purpose of this paper, there are two. One is to argue that logical empiricists can't account for scientific reasoning, which includes more than just figuring out the logical resources of the theory, right? So he's actually really concerned to show that one can't go and articulate any kind of accounting metaphor or analogy by talking about the logical resources. The other purpose, and this is one that I don't really have my head fully around, he wants to use U and P fertility to give an argument for realism. That if something like, I'm going to give a really, I don't even want to give this version of the argument, it's so Bugs Bunny. But if a theory evolves successfully, then it's somehow fit for survival, it somehow latches onto the world. You need some kind of world theory relationship in order to be able to explain the success success of its evolution. And let's see, ruin the notion of infertility. Maybe, can you say more about what you mean by ruin?
Well,
Because he definitely wants it in there, and he wants there to be a relationship between you and infertility so that he can deny this view that all we have are logical resources.
yeah, I mean, I'm thinking of some of his later stuff where he talks about hypothetical structuralism, where he's trying to develop the idea that we can have a rich theoretical structure that we confront with reality and or experiment, but it is nonetheless it's still HD, and that's and I mean he criticizes Newton because Newton is just presuming more of the same. We really need this idea of just plain old HD to allow us to have this this confrontation of new stuff, novel stuff. Right? I just want, I mean, part of the thoughtful question I wasn't able to articulate is that focusing on McMullen like this, or starting from McMullen, puts eufertility in the wrong kind of frame. And I think that maybe the idea of this kind of eufertility would be better thought of as not something like this, but as explaining what it means for a theory to be extendable, or I'll ask you about this later.
I mean, if what you're saying is why am I going and connecting this to evidential support when really it belongs in a different place? Is that?
I think it belongs to evidential support, but I think I'm worried about starting with McMullen. I'm worried that he's framing it in the wrong kind of way, but maybe I'll develop that myself.
That's entirely possible.
So is that a hand or finger?
It's a figure from the question before. It
Okay.
took me a while to figure out what it was about. Sorry, so
Okay.
it's not a, okay. I think that I'd like to, there's a lot of work going on with looking at vitamin D and certain kinds of things it's good for. And now, I know somebody that's working on testing for side effects for various drugs. And it turns out that when they give this vitamin D compound to rats, the rats die. And it turns out vitamin D was actually used as a rat poison earlier. I mean, and so they're having a great deal of trouble getting people to take seriously this vitamin D thing for humans, which has all kinds of good effects. Because, man, they give it to rats that just die. And they've started to do work with a kind of monkey, which is much closer to humans. And it turns out that to get this particular bad effect that kills the rat to go on to happen in a monkey, you would need like thousands and thousands of times the dose that would do it for a rat. And they're trying very hard to get this effect with the monkey to be able to be taken by, I think it's, by whatever drug regime would allow this thing. And now, can you use, I mean, presumably the monkey is closer to humans, and so the fact that you don't get that effect, in fact, the amounts you would need would be so much higher than the things that is this the sort of thing? It seems to me this is sort of a little bit like George's question, but a case where how to put it, the monkeys are more like humans in a relevant way, that you should be able to allow this to offset the bad stuff that's coming from the rats. So.
I think that reveals one of the ways in which analogies are very vulnerable. In that, so this, say something like this unless T, we may not find out about it. There may be a mystery unless T that's taking place. So in the the case of the rats, there's some way in which they're different that we didn't know until testing with vitamin D, and then we find out that monkeys are similar in that respect, right? And in order to test the horizontal relationship of in that respect, that's actually a matter where you're going to have to test. And I think in that place, P fertility is actually going to be crucial. And eufertility, I'm not conceiving of eufertility as something that tells us what is more likely to be confirmed. Okay, when I go on, I connect it to our notion of evidence. What I'm connecting it to is something more like its testability, rather than how successful it's going to be afterwards. So yeah, that's, I mean, I thank you for the example. That's a good one. That's going to be a case where you are going to be crucially dependent on after-the-fact tests or information after the fact.
Okay. I was struck by the example you cited where it was found that cognitively, apparently, human beings take about as much time or much effort to process metaphor and literal statements. And it struck me that maybe human beings always process language metaphorically, sort of metaphorical mode, in the same way that our memories work associatively, rather than indexically like the computers would. And do you think that might be true, and that might help figure out how we think about scientific theory?
Right. So do I think that might be true? Okay, first of all, the absolute honest answer to that is going to be, I don't know, and it's going to depend. There are going to be certain cases where we might more naturally think metaphorically first. They might be cases where we are feeling very uncertain. I mean, what you're talking about opens up a massive can of worms, so we would need to answer questions like, when do metaphors die, for example? So in order to look at the psycholinguistic research, did they actually offer a metaphor to the subject? Or was it, if it's going to be an ordinary metaphor? Because, I mean, if you offer to the subject something like, this is T.S. Eliot's, he laughed like an irresponsible fetus, it will take everybody an infinite amount of time to be able to interpret that sentence. So we are going to have to consider the kinds of examples that are being used. There's a fair amount of work being done right now, a lot of interesting books that I just got on my bookshelf that I haven't had a chance to read because they arrived a few days before I left to come here, about how we think metaphorically most of the time, and that there are levels and levels of metaphors upon metaphors that account for our cognitive structure, account for the way we perceive the world. And I know that Lakoff and Johnson argue that the kinds of inferences we make, the kinds of things that we pay attention to, the kinds of things that we see as similar or dissimilar, depend in part very crucially on the sorts of metaphors that we inherit as being a member of a particular socio-linguistic community. So if that's true, then one would need to look at that in order to address the question of scientific creativity. So how scientific creativity works, or how human creativity in general works.
Chris?
So let's say we take the point from McMullen to be some, I haven't read the paper, but something like there's a kind of non-algorithmic process by which scientists extend successful techniques to this familiar theory to cover new areas. Right? So, and you want to have a sort of psychologically realistic, naturalistic account of how that process goes. And you assume that it's not just using logical resources of the theory. There's a question that was bothering me throughout the talk. Why I think that process is going to be similar to the analysis of metaphors, which looks like more like a semantic concern. So I think maybe I was initially thinking it would be more like what you're describing towards the end in terms of processing analogies.
Right.
So why does McMullen make that initial move of saying, well, it's a metaphorical process that we should see?
Well, I'm not sure why McMullen does. I mean, I decided to take McMullen fairly literally. And so when he talks about metaphors and analogies, I want to see, are these in fact as non-heuristic as he supposes. He was, this article is from the 70s. Mary Hesse had recently published the influential book on metaphors in science. You see, I guess a little bit later, Richard Boyd talking about theory constitutive metaphors. So there is this idea in the air that scientific theories are metaphors, and that our job is actually to articulate the interpretation. So if you go with an error and paraphrase account, our job is to go and figure out what the paraphrase is and get it as detailed as possible. Once that's done, then the testing can begin. So I think that was a fairly common view. Also, I mean, there's this, depending on what period metaphor you have, there's a real sense in which metaphors are structurally very similar to analogies. It's just that one is about meaning and the other is about inferences. But if they're both about transference of structures from one domain to another, they're going to function in very similar ways. I don't know if that answers your.
Yeah, so I mean,
I'm not a McMullen
right. So
theorist,
let me then. So the initial thought was that if you're interested in giving a sort of naturalistic account of how certain processes work, it seems that the processing of metaphor at the kind of semantic level, as you're describing a lot of these computer models is doing, seems quite different than, at least on the surface, the kind of transference of inferential structure that you're describing in terms of analogical reasoning. And you're just giving me some ways of seeing how those are connected. But initially, it wasn't clear to me why the cognitive process that is involved in responding to metaphorical language would be the same as the one that seemed to be the real focus, namely, how is it that scientists extend what looks like the potential of, how do they realize the potential of the theory? And why is it that those two processes are going to be the same? Or how are they linked? So I think you've given me some reasons for seeing them if you want, but that was the initial question.
Oh, I see.
Well, let's thank our speakers.